Okay, so my name is Arjun, and I will be proving that angle 5 is congruent to angle 9 in this figure for my Unit 2 assessment. Yay! Alright, so I've already copied down what we know and what we are trying to prove for efficiency purposes, and I've already worked through this problem, so I know how many steps there are. Right, so let's just jump right into it. Right, so what we already know, what's given to us, is that line AB is perpendicular to line AD, as well as line DC is perpendicular to line AD. So based off of this, we can safely assume that line AB is parallel to line DC. Now this is because of a little rule I like to call lines perpendicular to a common line rule. Now, I can't actually remember the name of this rule off the top of my head, but I assure you it is a real rule, and basically what it states is that if there are a pair of lines perpendicular to the same line, then the pair of lines are parallel to each other. Right, so now we found one crucial piece of information. Now the next one we know is that line FB is a transversal to lines AD and DC. And we know this because, sorry, not AD, AB, my bad, AB. And we know this because of the definition, definition of a transversal states that a transversal is basically any line that intersects a pair of lines, like clearly and distinctly. So we can clearly see that line FB here intersects line AB right here and line DC right here. So two very clear, distinct intersections. Now, with these two pieces of information, we can safely assume that we can start using theorems that have to do with parallel lines and their transversals, such as alternate interior angles theorem, alternate exterior angles theorem, corresponding angle theorem, yes, and such. So for this one, we're going to be using the alternate interior angle theorem. Now this is because this theorem states that alternate angles, as you can see, they are both on either side of the transversal, and they are also like across the way, and they're on the interior. Basically, this is the interior, and out here is all exterior. So we've already got alternate, interior, and then these are the angles, of course, right? And so this theorem states that these angles would be equal, as would 8 and 4. Yeah, so in this figure, angle 5 does in fact equal angle 9.